In the previous videos, we talked about different examples of subnetting. Now in this video, we will go over Class C subnetting and we will talk about the network bits, host bits, and subnet bits, and how can we calculate all that. So stay tuned, let's jump into my computer and take a look. So we already know Class C range is 192 to 223. So when we see IP address with the default subnet mask of 255.255.255.0. So when we see IP address of, let's say, 200.18.65.20, this is an example of Class C IP address. How do we know? Looking at the first octet, 200 falls into this range between 192 to 223. So that's an example of Class C IP address, and the default subnet mask is the first 3 octet belongs to the network and the last octet belongs to the host, with the default subnet mask of 255.255.255.0. And if we want to write down the prefix /24, which means 24 bits is a network bits going from left to right. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is the default cut line, and here the rest it's 0, which is our host bits. 1s represents network bits, 0s represents host bits. So that's the default subnet mask for Class C. And using the default subnet mask, Class C, we already know the number of hosts, 2 to the power of host bits minus 2, because of the network address and the broadcast address. We cannot use them, right? That's why we do the minus 2. So how many host bits do we have? Zeros represents host bits. We have 8 zeros, 2 to the power of 8 minus 2. That's 256 minus 2, which is 254. So 254 available IP addresses we have. So this is one big network with 254 available IP addresses. But let's say we don't want to go with default subnet mask. So this /24. Let's say we want to go with /27. One example here. So is this /27, is this a default subnet mask? No. That's a classless interdomain routing. That's a classless subnet mask. So what does it mean? It means that we have 27 bits turned on for the network bits. So let's count. 8 plus 8, 16, plus 8, 24, 25, 26, 27. So this is our new cut line. We move the cut line from left to right. That's an example of subnetting. We will have more subnets and less available IP addresses per subnet. So all this turned on, and all the original network bits based on the default subnet mask, known as network bits, and when we borrowed from the host bits, known as our subnet bits, and zeros means host bits. So this /27 will give us different value. Let's write down our 27 here, /27. So the subnet mask would be this 8, all the 8 bits turned on, so that's 255. So here we can see 255. Second octet, all the 8 bits turned on, 255. The third octet, all the 8 bits turned on, 255. On the last octet, we have only 1, 2, 3 bits turned on, which when we convert this binary to decimal, we just need to count and add the decimal values of the ones that's already being turned on. In this case, 128 turned on, 64 turned on, and 32 turned on. So 128 plus 64 plus 32, which is 224. So this is our new subnet mask based on this CIDR notation. And we know this subnet mask, it's not the default subnet mask for Class C, because default subnet mask Class C, you guys already know, 255.255.255.0, not 255.255.255.224. So this 224 means 3 bits borrowed on the last octet. Here we can see 224. If we convert decimal to binary, we get this binary number. If we convert binary to decimal, we get this decimal number. So the CIDR notation of 27, the subnet mask is 255.255.255.224. Now how many available of subnets we have? Well, the number of subnets 2 to the power of subnet bits. How many subnet bits we have? So the bits that we borrowed from host bits, they are considered subnet bits. 1, 2, 3. 3 subnet bits, right? 2 to the power of 3, which is 8. How many available IP addresses we have per subnet? Well, let's find out. So how many, so we talked about this formula to find out the number of hosts. 2 to the power of host bits minus 2. 2 to the power of host bits. What's our host bits? Zeros represents host bits. 1, 2, 3, 4, 5. So 2 to the power of 5 minus 2, which is 32 minus 2, 30. So it gives us 30 available IP addresses, which you probably saw on previous videos. I talked about number of hosts. You can start with number 2 and going from right to left, 2, 4, 8, 16, 32, minus 2, 30, and we have to do the minus 2. That's the number of hosts. If you don't want to go by the formula, and the number of subnets for those subnet bits we borrowed from the host bits. So going from left to right for the number of subnets, starting with 2, 4, 8. That's also another way to find out number of subnets, 8, and number of hosts, 30, as we can see. So yeah, you can also do this going from left to right for the number of subnets, starting with 2 and double, or going from right to left, starting with 2 and double the number, and then making sure at the end doing the minus 2 till the cut line, where the cut line is the line between the zeros and ones, or by just using this formula. So if we see a class C network address with a subnet mask of 255.255.255.224 or the CIDR notation of 27, it will give us 8 subnets, each subnet 30 available IP addresses. This was an example of class C IPv4 subnetting, the differences between network bits, subnet bits, and host bits, which again, anytime when we borrow from the host bits, considered subnet bits. In this example, /27. which we borrowed 3 bits. And also, as previously we talked about, it's a table that we can learn and memorize. Anytime when we borrow 1 bit, it's 128. When we borrow 2 bits, it's 192. When we borrow 3 bits, 224. When we borrow 4 bits, it's 240. When we borrow 5 bits, it's 248. And when we borrow 6 bits, it's 252. When we borrow 7 bits, 254. When we borrow 8 bits, 255. So in this example, we borrowed 1, 2, 3, and the cut line is here, right? 27. So originally we had 24. That's the default subnet mask for class C. 25, 26, 27. So 3 bits borrowed, right? Which is 224. And here, as we can see, 224 on the last octet. We're working on the last octet. The cut line is on the last octet. So we just write down 224 on the last octet. Or in other words, when we convert this binary to decimal, that's 224. And these values, again, it's just coming from the decimal values to the top. How many bits turned on? We just add them. And it goes from left to right, the number of ones when we borrow. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.